Hey class, one of your classmates emailed and asked for a video on how to find zeros of a function. And so I just want to show you what I did behind the scenes so you know where all of this is coming from. So what I did was I took first a polynomial already factored. You can see the zeros. If this was 0, add 3, divide by 2. So you would get 3 halves, which is 1.5. This is 0, we would get negative 3. So we have zeros of 1.5 and negative 3. So let's see how that works. What I've done though is I took this and foiled it out so that this is what I will be graphing. So let's take that and look here. So in the y equals, this calculator, by the way, is supposed to be a TI-84-ish. It looks a little bit different, but the buttons are in the same spot, and you'll be able to see what I'm doing. So I hit y equals, and I type that function in. The next thing I'm going to do is hit the graph button over there on the right-hand side above the direction buttons. And in order to figure out where the zeros are, I'm going to use the calculate function. Notice up at the top, next to the graph button, it says trace, and above trace it says calc and F4. Calc is in blue, so I'm going to hit the blue button, and then I'm going to hit trace. Notice option 2 there says 0, so I'm going to say pick a 0. And now it's going to ask me, notice at the top in the middle, it says left bound question mark. What I'm going to do is I'm going to mark a spot over here, and I'm going to hit enter. That put a red vertical line at the left bound. What I'm trying to do is find something on the left side of the 0 and something on the right side. So I'm going to hit the right arrow a couple times, and notice my value has went now on the other side. And so now it's negative as the graph sits. And so I'm going to hit enter there. And now in the lower left-hand corner of the screen, it says there's a 0 at negative 3. And so if I drag the point up to it, you can see as the point sits on top of that, it is very close to negative 3 when we hit our 0. If I hit calculate again, down to option 2 and enter, this time I'm going to hit a value on this side as my left bound. I'm going to hit the right arrow a couple times to get to the right side. And in this case, it says down in the lower corner that the 0 is x equals 1.4999997. That's basically 1.5, and we know the answer really is 1.5. So that is how you would do it on a calculator. What I wanted to show you, though, further is this, because this is kind of neat. So once I took that factored form of the polynomial and multiplied it out, this is coming before the end of the term, but I figured out what function would I take a derivative of to get that function right there. And what I did was I said, well, to get the 2, I should make that a 3. But that 3 is going to pull down, and so I'm going to divide by 3, and that's why there's a divide by 3, and that went to a 3. That's a 1, and I said, well, to get that to be a 1, that would have to come from a 2. But that 2 would pull down, and so if I divide by 2, that's where that came from, the divide by 2 would make that work. And this would come from just a 9x, because the derivative of a minus 9x is negative 9. So this function has this as its derivative. And here's what I wanted to show you now with that. So there I have the function graphed in red. You can see it is a cubic function. Now I'm going to turn on the derivative, so that is its derivative. 2x squared plus 3x minus 9. And that derivative has a couple zeros, and we can see them right here at negative 3, and another one right there at 1.5. That is very specific, because we have already said that this gives us 3/2, which is 1.5, and this factor gives us -3. So we should expect a -3 and a 1.5 as those values. On those then, if I light up vertical bars at those values, you can see at this value down here, we're at 0, we do have a max on the red graph right there. That is shown by, if I turn this off, this is the actual sign chart right here. So what would happen if we were trying to find mins and maxes of this function? What would happen is we would take the red function and we would find its derivative. Here's its derivative. Then we would find zeros of the derivative. There are the 2 zeros right there. Then we would put them into a sign chart. So here's what happens. We take this function, we take the derivative. So y prime is 2x squared plus 3x minus 9. We set it equal to 0. We would find that we would get values of 3/2 and -3. Make a sign chart. Here's the -3, and here's 3/2. Pick test points, -4, 0, and 2. These values get plugged into the derivative now. Now, here's the thing. The derivative, I can already see at any value over here, the function is always positive. And so any value I pick over here, there's going to be a positive value for that. So this would be a positive. When I plug in 0, clearly at 0 you can see I'm at -9. But anywhere in between, the function is always negative. And by the function, I mean the derivative. And so therefore, in the notes, we put a negative here. And then at 2, if we throw in a 2, well, right here, the value at 2 is very close to 4 something. But on this side, the function, the derivative of our original function is always positive. And so because it's always positive, we'll put a plus there. Now, if it increases and decreases, there should be a max at -3. And if it decreases and then increases, there should be a min at 3/2. So we set a max at 3. Oh, yeah, right, there's a max at 3 and a min at 3/2, or 1.5. So there you can see how the zeros of a function of a derivative directly correspond to mins and maxes of the function. But moreover, if you take the function away, the derivative actually is a graph of the sign chart, where in this region here, we would put a plus. In this region down here, we would put a minus. And in this region up here, we would put a plus again. And so that directly corresponds to the mins and maxes that we find there. In the calculator, incidentally, the function that I chose was the derivative in that example, and so therefore, when we graph this, the zeros right here at -3 and the 0 here at 1.5 both correspond with what we saw in Desmos as well. But the button that you want to push for that is second and trace and pick option 2 to find the zeros. All right? Hope that helps. Take care, guys. Bye-bye.